All right. Now, what's the next row? Well, the next row, column, is what happens when you have 3 terms. So we need to figure this out fast. That once and what I told third hour, this is like files in your brain. You got to organize your files and get these understood. Oh, when I see 2 terms, if there's no GCF, I only have a difference of cubes, sum of cubes, or difference of squares. And this is the way I factor. Now it's this file. When I have 3 terms, we do an MA. Okay? But why are these 2 different? Why are these 2 examples different right here? How is one different than the other? Huh? One has a number, what? In front of the x squared. All right? We know that's a different type of factoring. But this one's not. Who is the m number in this first example? Who represents the m? 36. Who's the a number? It's actually what kind of 15? Okay, now, you could do a table. I couldn't care less. I never did a table with my students back in the day. We never did tables with that Foundations of Algebra 2. I just had them put an m in front of 36, an a in front of negative 15, and figure out the numbers. So those are the numbers. What do we do about it when it's 1x squared? Well, by golly, that was the answer. I didn't have to do anything else. What is the answer when I factor this? Come on, guys, what is it? X. I don't care which one I write first. When you find the numbers, those are the factors, and I can prove it. What's x times x, everybody? X squared. What's negative 3 times negative 12? 36. And then what's the middle term going to become? Actually, negative 15x. Negative 12x plus negative 3x. Don't confuse yourself and actually do that. You're going in circles. This is the factored answer. All right, so let's move on to the next one. Those that know, what is m in the next one? See, this 3 messes up everything. What is m? It's actually negative 30. Negative 3, or 3 times negative 10. And then what's your a number still? Okay, so m is negative 30. What's your a number? 1. Okay, offline, we'll figure out what the numbers are. Number 4, period 6, shares out. Sharing is caring. That these are the numbers. What do we do about it, though? We can't do this. This is not right. How do I know this is not the right answer? Look at first. What's x times x? Not 3x squared. And then look at last. What's 6 times negative 5? Negative 30, not negative. So that's not what you do. What do we have to do now? Well, this is when we take 3x squared, and then what do we do with these 2 numbers? Put them in. Split up the middle term. Split up the middle term to match the magic numbers. But then leave the 3x squared and the negative 10 alone. Now, I made this difficult. I did this on purpose because when you factor by grouping, you got to be careful. What should I do with this minus sign? Make a plus a negative, then factor by grouping. Okay, so this one you have to go ahead and do that first thing that I showed you, factoring trinomials. Got to do it. Okay, so what do we pull out of the first set of parentheses? Pull out an x. Actually, I disagree, a 3x, right? And then what are you left with? So be careful. And then you got to make these match. So what am I going to pull out of the second set of parentheses? Not just a 5, but a negative 5. And then this is what should happen. Negative 5x divided by negative 5 is x. Negative 10 divided by negative 5 is 2. And then this is called a binomial GCF. By golly, I'll even highlight them for you. What you can do then is pull that binomial GCF out in front. And then basically what's left over when I pull those out? 3x minus 5. It's not like I'm destroying them, but what I'm trying to get you to visualize is that's what's happening when you factor out that GCF that's a binomial. Okay? Classes. Okay, why did I put these here? Well, you know what? This is actually just an MA. But look at what the answer turns out to be. What multiplies to 1 and adds to 2? Because I do have a trinomial. What 2 numbers multiply to be 1, add to be 2? What is it? 1 and 1. No, it's just 1 and 1. It's 1 times 1, 1 plus 1. 1 times 1 is 1, 1 plus 1 is 1. So what does that mean this factors to become? X plus 1 times x plus 1. What is x plus 1 times x plus 1? X plus 1 squared. So actually this is called a perfect square trinomial because it ends up being a binomial squared when you are done factoring. You don't have to write it like this, but I'm just giving you why it's called that. Well, look at this one. It's a trinomial. What is m? Ooh. What is m? No, it's not 9. Whatever 9 times 16 is, which is, oh, these are big numbers. And actually, this one you may be able to survive. 1 multiplies 144 and adds to negative 24. Negative 12 and negative 12. And then guess what? You can do all of it. You said it, right? Didn't you say negative 12 and negative 12? Okay, well, you look shocked like I was giving you student number 20. Good job. All right, you're online now. Famous. Okay, then you could do all of this. But no. No, no, no. Watch this. What's the perfect square of 16x squared? What times what equals 16x squared, everybody? 4x. And then what's the perfect square of positive 9? 3. But look, you have a negative middle term. What happens if I put a minus and a minus there? Does that work, yes or no? Absolutely, it works. What's 4x times 4x, everybody? 16x squared. What's negative 3 times negative 3? 9. And then what happens to the middle term? It don't cancel. Heck no. I must have said something else there. What's 4x times negative 3? Come on, you're killing me, Smalls. Negative 12x. What's negative 3 times 4? Negative 12. What's negative 12x plus negative 12x? Negative 24x. So actually, this is 4x minus 3 squared. Now, you may throw that one out of your brain if you don't want to think about that. You could have MA'd that and done it like that long one that we just did with the 3x squared. But what I want you to understand is there is a little extra pattern if you can handle it. Okay, now I have one more. We are exactly where we were in the other class, so I'll leave you alone after these last two. It was still taping. Okay, we're back on, I think. All right. These stick out like a sore thumb. How many terms do you count? How many terms? 4. Unless there's a big GCF, whatever. When you see 4 terms, that automatically you should be trying grouping. What is grouping? You take the first 2 terms. It's like a zoo out there. Do you hear them? And you group the last 2 terms, right? Okay, so what can I pull out of the first set of parentheses? 2. And you should definitely be up by now. I've kicked you 4 times on accident. Okay, all right. And then what's the second thing that you can pull out of this? You can pull out an A. Get that A to be looking really like an A there, so it doesn't look like anything else. All right. Then what do? You can pull out this x plus y. And you're left with what when you pull this x plus a out? 2 plus a. I think I said x plus y. I meant x plus y. I said that wrong, my bad. And then you end up with 2 plus a out in front. Okay, then the last one. I wish I made this more of a challenge. I wish I had a minus sign in between. What if that was a minus sign? What should we do? You should make a plus a negative. You should. You know what? I was mean on this, and actually I kind of screwed this up first hour. What did I say up at the top of the worksheet? Make sure you don't have an overall GCF when you're factoring. Do I have an overall GCF in this one, yes or no? Absolutely. What do you have? You have an x squared, not a 4. I heard someone say that. Only one term messes that up. Which term does not have a 4 in it? First, second, third, or fourth? Third. So 4 was close. But only an x squared could be yanked out to start off with. Then you have a negative 4. Minus 16x squared plus ax plus 4ax cubed. So I want to make sure I got all those counted correctly when we pull that out. Now what you need to understand is this. This will just be a part of our final answer. It'll be x squared times, and then I'll have a couple sets of parentheses here when I'm done. So if you want to forget about that for right now, it's probably smart. But again, when you factor completely, that needs to come into your final answer. Then on the inside, we are going to group. So I'm going to just change colors on that. What is the greatest common factor in this one? It is -4. You should definitely take out a -4. And then what are you left with? 1 plus 4x squared. And then what should you take out of this one? Only an a. And then what are you left with? I'm sorry, wrong. ax. Good, whoever caught that. Nicely done. Take out an ax. What's ax divided by ax? 1. And then what's left over here? 4x squared. Actually, I have way too much space because this is over. This is the same. So this is factored out as a binomial GCF. And this is what I'm left with. So there was only one example on this of factoring completely, meaning taking out a GCF first, then proceeding on and factoring what's left over. So grand finale. Okay, the next time, the only time we're going to see factor anymore is with review with other stuff. You have to have your files organized. When I have 2 terms, 3 terms, 4 terms, what should I do? And this is the last time we can actually, do this, to make sure we get this all figured out.